Hello students and welcome to my channel Maths Hub. So today in this video, I'll tell you about the first shifting property of Laplace as well as inverse Laplace transforms, right? So if you are watching my videos, we have done the first property on linearity and now the second property is the first shifting property. So let's first understand what is this property all about. So for Laplace transform, the first shifting property says that if for the function ft the Laplace is fs, then if I multiply the function with an exponential term, then what happens? S gets shifted to s minus a, and hence the naming is done as the first shifting property. That means if we know the Laplace of any function ft, and that function is multiplied with an exponential function e raised to power at, then what is the change in its Laplace? S will get changed to s minus a, right? Now let us understand what is the first shifting property for inverse Laplace transform. So for inverse Laplace transform, it says that if for fs its inverse Laplace is ft, then if s is getting shifted to s minus a, then what is the resultant answer? Ft will get multiplied with the exponential function, right? So it is a two-way process. If we have the function ft and we know that its Laplace is f of s, then if I multiply this function with e raised to power at, then what is the change? Then this s will get changed to s minus a, right? And vice versa, if I know that the inverse Laplace of f of s is ft function and I have to calculate the inverse Laplace of f of s minus a, then what happens to this function? This function will get multiplied with e raised to power, right? So this is the nutshell of the first shifting property. So let us try to apply this as in question and try to understand this property, right? So the first exercise says that we need to calculate the Laplace transform of t cube multiplied by e raised to power minus 2t. So there is no formula for a product term in Laplace. So in my last video, I told you that if we have two trigonometric functions like sine and cos, or two sine functions or two cos functions, you can always use the CD formulas to convert them into a sum or a difference, right? But there is no other formula for a product, right? But in the product, if you find that one term is exponential, then immediately it should strike you that we need to apply the shifting property, the first shifting property, right? So according to the first shifting property, just hide the exponential function and whatever function is left, take up that function, right? So we need to calculate the Laplace of this function. So in this product, we have seen that one of the function is exponential. So let us hide the exponential function and let us take what is the function left. The function left is Laplace of t cube. So let us calculate the Laplace of this function. So we know that according to the basic, I told you that the basic table formulas are very important because we are going to apply it in every question, right? So that should be learned by heart, right? And there are not many, only there are 4 to 5 formulas that you need to remember. And once you start practicing, you even don't need to memorize them. You will automatically get those formulas, right? So we know that Laplace of t raised to power n is n factorial upon s raised to power n plus 1. So we need to calculate Laplace of t cube. What is Laplace of t cube then? It is 3 factorial upon s raised to power 4. I've replaced n with 3. So 3 factorial is 6. 6 upon s raised to power 4. Now t cube is getting multiplied with an exponential function. So what did the first shifting property say? That whenever a function gets multiplied with exponential, just take e raised to power 80, compare it with this. Compare this term with e raised to power 80. So what is your a? A is minus 2. So if you remember, fs, you just need to replace s with s minus a. So what is your fs here? Fs is 6 upon s to the power 4. So what we are going to do? We'll apply the first shifting property. So wherever we have s will get shifted to s minus a. A is minus 2. So it will be s plus 2 whole raised to power, right? So it becomes very simple. So you just eliminate the exponential term, find the Laplace of the remaining function, and in that function just replace s with s minus a. So that becomes the application of the first shifting property, right? I hope the property is clear how we are applying it, right? Okay, so let us try to do one more question. We need to calculate the inverse Laplace transform of 1 upon s plus 2 whole raised to power 5. So let us see that what was the first shifting property for inverse Laplace transform. So the first shifting property said that if Laplace inverse of f of s is ft, then Laplace inverse of f of s minus a will be e raised to power at into f of t. So here you can see that s is getting shifted to s minus a. So in your problem, just check where is s getting shifted to. Can you see that s is getting shifted to s plus 2, right? So what will you do? Compare this s plus 2 with s minus a. So what is your a? A is definitely minus 2, right? So what we will do, in the first go, we will change s plus 2 to s. And let us try to calculate the Laplace inverse of 1 by s raised to power 5, right? So again, the basic table formulas tell us that if we have Laplace inverse of 1 by s raised to power n, our answer is t raised to power n minus 1 by n minus 1 factorial. So what is 1 by s raised to power 5? It is t raised to power 4 by 4 factorial. Okay. So now, if s is getting shifted to s plus 2, what will happen? The function ft, it will get multiplied by e raised to power at. So we have identified what is a. So what will be Laplace inverse of 1 upon s plus 2 whole raised to power 5? It will be t raised to power 4 by 4 factorial multiplied by e raised to power minus 2t. You will simply multiply the function with the exponential term, right? So what we did, in the first step, we had to calculate the Laplace inverse of this. So we saw that s was getting shifted to s plus 2. We compared s plus 2 with s minus a. So we got a s minus 2. We shifted s plus 2 to s. We got back the basic function, that is 1 by s to the power 5. We found out the Laplace inverse of that function. After finding out the Laplace inverse, what we did, we just applied the first shifting property and we multiplied the function with the exponential term, right? So this becomes our answer, right? So let us try to see some more problems. We need to calculate the inverse Laplace transform of this. Now it's again a complex term. So we need to find out Laplace inverse of this term. So you have seen that in the basic table formulas in inverse Laplace, in the denominator, we have the term s squared plus a squared. There is no other term in the denominator apart from this term. So if you check this term, it's a mixed term. We are getting a 4s term also. So what is the first step? Let us convert this term in this form. So how to convert it in this form? We'll try to reduce this into a complete square, right? So how to reduce this into a complete square? Let us see. So we have s upon s square plus 4s plus 13. So how to make a complete square? Middle term is 4s. So let us add half of the square and let us subtract half of its square, right? So what do we get? We get s upon, now s square plus 4s plus 2 will become s plus 2 whole square. 13 minus 4 is 9, so that becomes 3 square, right? Now looking at this term, you need to make the numerator similar. It is s plus 2, so try to make s plus 2 in the numerator. How will you make s plus 2? Obviously, you need to add plus 2 and subtract minus 2 from there. So now let's make a group of s plus 2. So, and let us split this term. We will get s plus 2 upon s plus 2 whole square plus 3 square minus 2 upon s plus 2 square plus 3 square. Right? So we have reduced this term here. Now let us try to take the inverse Laplace of this. So you can see that we can first apply the linearity property to split the terms. So when we apply the linearity property, we get Laplace inverse of s plus 2 upon s plus 2 square plus 3 square, the first term. In the second term, I can take out 2 common and I can get Laplace inverse of 1 by s plus 2 square plus 3 square. Right? Okay. Let us try to do this term first. Now, when we have to calculate this term, I can see easily that s is getting shifted to s plus 2. Right? So, what is our a here? If you compare it with s minus a is minus 2. Right? So if I replace this with s, my function will become Laplace inverse of s upon s square plus 3 square. And what is the Laplace inverse of this term? It is simply cos 3t. So which property will I apply here? The first shifting property. So when I apply the first shifting property, what will be the Laplace inverse of this term? It will be e raised to power minus 2t multiplied by cos 3. Isn't it? Right? Because you are seeing that s is getting shifted to s plus 2. Okay. Next term is minus 2. And then we have Laplace inverse of 1 upon s plus 2 square plus 3 square. So again here you can see that s is getting shifted to s plus 2. So you can identify your a as minus 2. So if I reduce this term, I'll get Laplace inverse of s square plus 3 square. So what is Laplace inverse of 1 by s square plus 3 square? It will be simply 1 by 3 sine 3t. So how will I get this term? When I shift s to s plus 2, that means I have to multiply with e raised to power minus 2t. So this term will become 2 by 1 by 3 e raised to power minus 2t multiplied by sine 3t. Right? So I can do one more step. I can take out e raised to power minus 2t common and I'll get cos 3t minus 2 by 3 sine 3t. Right? So this becomes my answer. Right? Okay. So let us do the next question. So we need to calculate the Laplace inverse of s minus 1 upon s square minus 6s plus 25. So again, looking at the denominator, we have to fix our numerator. So how to fix the numerator? So let us complete the squares. We have s minus 1 upon s square minus 6s plus 25. 6 we have, so let us add half of it, that is 3 square, and let us subtract 3 square from here. So this is s minus 1 upon s square minus 6s plus 3 square. That will become s minus 3 square. 25 minus 9 is 16, so that will become 4 square. Right? Now what do I need to add and subtract in the numerator to make minus 3? I can subtract 2 and add 2. So this expression will become s minus 3 plus 2 upon s minus 3 square plus 4 square. So I need to calculate the Laplace inverse of this term, right? I can split this. So this is Laplace inverse of s minus 3 upon s minus 3 square plus 4 square plus 2 times Laplace inverse of 1 by s minus 3 square plus 4 square, right? So now, if you check these terms, let's do it mentally. You can see that s is getting shifted to s minus 3. So if you compare it with s minus a, your a becomes 3. So your basic function is basically s upon s square plus 4 square. So what is its Laplace transform? It is cos 4t. And you are shifting s to s minus 3. So by first shifting property, exponential term will get multiplied with this plus 2 times. So the basic function is again 1 by s square plus 4. So it will be 1 by 2, then sine 2t, but s is getting shifted to s minus 3. So we need to multiply with e raised to power 3t. So 2 gets cancelled. We can take out e raised to power 3t common and we get cos 4t plus sine 2. So this becomes our answer, right? So looking at the denominator terms, we need to manipulate the numerators and then we need to see that how the first shifting property is applicable in the question, right? Let's do one more problem. So we have to find the inverse Laplace transforms for this. So now here you can see that we have 5s, and when we split this term, you can see that we can make linear factors of the denominator, right? So if I make the linear factors, it is s minus 3 into s minus 2. Where factors are possible, it is always advisable to make the factors, right? If factors are not possible, then try to make the squares. So I need to calculate Laplace inverse of 1 by s minus 3 into s minus 2. So which trick is applicable here? Can we apply partial fractions to split this term? Yes. So let us apply the partial fractions. 1 upon s minus 3 into s minus 2 is equal to a upon s minus 3 plus b upon s minus 2. Now, a trick to calculate the coefficients a and b. When you are calculating the coefficient of a, it is above s minus 3. So put s minus 3 equal to 0. So you will get s is equal to 3, right? So when we put this is equal to 0, so we'll get s is equal to 3. Now hide s minus 3 in this expression and put s equal to 3. You will get 1 upon 3 minus 2. So a becomes 1. When you are calculating the coefficient of b, put its denominator equal to 0. So s is equal to 2. Hide s equal to 2 and put it in this expression. So b becomes minus 1, right? So this is nothing but Laplace inverse of 1 by s minus 3 minus 1 by s minus 2. So again, using the linearity property, I can split them. This is Laplace inverse of s minus 3 minus Laplace inverse of 1 by s minus 2, right? So again, using the basic table formula, so what is Laplace inverse of 1 by s minus a? It is e raised to power at minus e raised to power 2, right? So this becomes our that. I'll give you one question as a practice. So you have to find out the Laplace inverse of s plus 4 upon s minus 1 s square plus 4. So you don't have to worry about this question. So you can see that there are three product terms in the denominator. So you can use partial fractions. You can split this term as a by s plus b by s minus 1 plus, this is a quadratic. So you can write it as cs plus d upon s square plus 4. So by cross multiplying, you can compute the coefficients of a, b, c, d. And then you can apply the linearity property of inverse Laplace to split all these terms. And then you can easily calculate the inverse Laplace of each of them. So try this question, though the answer is given here. So you can see that on applying the partial fractions, we get the coefficients as a as minus 1, b as 1, c is 0 and d is minus 1, right? And then you can easily apply inverse Laplace And when you apply the inverse Laplace, you'll get this expression. So Laplace inverse of 1 by s will become 1. Laplace inverse of 1 by s minus 1 will become e raised to power t. And Laplace inverse of 2 upon s square plus 2 square will become 1 by 2 sine 2t. Right? So don't look at the answer first. Try it on your own and then check it. Right? So I hope you have understood the force shifting property. Right? So if you like the video, do hit the like button, and those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. So believe in yourself and you will be able to succeed. Thank you so much.